Hello everyone. I am Dr. V. Sureshkumar, Associate Professor of Chemistry and Head of the Department, King's College of Engineering, Punnankulam, Tanjavur. So today I am going to deliver a lecture about the working principle of light water nuclear power plant. So before going to the working principle of light water nuclear power plant, let me know some basic concepts of what is nuclear fission reaction. So what is nuclear fission reaction? When uranium-235 is bombarded by thermal neutron, so that thermal neutrons hit the uranium-235, then the uranium-235 splits into two approximately equal parts with the liberation of large amount of energy. So this is the principle behind the fission reaction. Then the definition of nuclear fission. So nuclear fission is defined as the process of splitting of heavier nucleus into two or more smaller nuclei with simultaneous liberation of large amount of energy. What is the mechanism of nuclear fission? So when uranium-235 is bombarded by a thermal neutron, so unstable uranium-236 is formed. So the unstable uranium-236 then divides into two approximately equal nuclei with the release of neutrons and a large amount of energy, which is the mechanism of this fission reaction, which is clearly indicated in the above equations. When uranium-235 is reacted or bombarded by thermal neutron, it forms uranium-236. It is unstable one, it is in square bracket. Then the unstable uranium-236 split into two lighter nuclei and simultaneously liberates three neutrons and energy. This is the diagrammatic illustration of this fission reaction. So neutron is bombarded to uranium-235, then it forms unstable uranium-236, and this unstable uranium-236 split into two lighter nuclei plus three neutrons plus enormous amount of energy will be released. What is nuclear energy? The enormous amount of energy released during the nuclear chain reaction of heavy isotope like uranium-235 or polonium-239 is called nuclear energy. So definition of nuclear energy. The energy obtained from the conversion of nuclear mass due to nuclear fission or nuclear fusion is called nuclear energy. So this is diagrammatic illustration. So neutron which is bombarded to uranium-235, then simultaneous liberation of three neutrons with large amount of energy. What is the reason behind that? That is the reason behind the loss of release of energy or loss of mass. That is causes of release of energy. The enormous amount of energy released during the nuclear fission is due to the loss in mass when the reaction takes place. So it has been observed that during nuclear fission, the sum of the masses of the products formed is slightly less than the masses formed in the target species and bombarding neutron. So we are all very well know the target species is uranium-235 with bombarded with neutron. When we calculate these two masses and when we subtract these two masses with the product mass, there is a slight difference in the mass. That slight difference is coming out as a energy release. So the loss in mass gets converted into energy according to Einstein equation. So Einstein equation is E is equal to mc square, that is delta mc square, where delta m is m minus m dash. What is m? M is equal to mass of radioactive substance before emitting radiation, whereas m dash is mass of radioactive substance after emitting radiation. C we are all very well know, C is the velocity and E is the energy. So we are all very well know nuclear energy is very hazardous in nature. So what will happen when we are using this nuclear energy? So these produces harmful radiations that is very harmful to living organisms. The nuclear radiation can damage the structure of cells in the body. It also causes cancer and blindness. Also, it causes genetic disorder in human body. What are the applications of nuclear energy? So, application of nuclear energy is applied to produce electricity generation, that is nuclear power plants, then produce pure water. It also used in healthcare departments and agriculture department. Then we will move to the types of nuclear fission reaction. So, nuclear fission reactions are of two types. One is controlled nuclear fission reaction and another one is uncontrolled nuclear fission reaction. First, we will see what is uncontrolled nuclear reaction. If a nuclear reaction is made to occur in an uncontrolled manner, then the energy released can be used for many destructive purposes. So, the example is atom bomb. So, once the bomb is bombarded, it is going as an uncontrolled manner, it produces huge amount of energy, that is destroyed everything. So, we will know about the incident of Hiroshima and Nagasaki. So, both cities are bombarded with an atom bomb by US Air Force. Both cities are totally destroyed. So, this is uncontrolled nuclear fission reaction. What do you mean by controlled nuclear fission reaction? Nuclear fission reaction is made to occur in a controlled manner, then the energy released can be used for many constructive purposes. For example, nuclear reactor. How it is controlled? So, nuclear reactor, the chain reaction can be controlled by inserting the control rods called boron or cadmium. These control rods absorbing all the neutrons except one in the reactor core, thereby the reaction will be controlled. So, in nuclear fission reaction, we are all know when we bombarded thermal neutron with uranium 235, there is a 3 neutrons will be produced. So, these 3 neutrons will start the chain reaction. So, when we inserting boron or cadmium control rods into the reactor core, what will happen? The boron or cadmium control rods will absorb the excess neutrons, that is out of 3 it absorb 2 neutrons, release 1, and this one will propagate the chain reaction. There it will be, the reaction will be controlled. So, 1 neutron is available for existing further fission reaction. Such a reaction is called controlled nuclear fission reaction and the energy release can be controlled. Then we will move to the real part of today's lecture, that is nuclear reactor, which is also called as pile, that is the arrangement of equipment used to carry out fission under controlled condition is called nuclear reactor. So, the arrangement of equipments used to carry out nuclear fission under controlled condition is called nuclear reactor. So, example, light water nuclear power plant. So, what are all the components of light water nuclear power plant? For this, we will go to the diagrammatic part of this light water nuclear power plant. So, in this light water nuclear power plant, the first part is fuel rod, which is denoted in a strip in black color. Then the control rods, which is denoted as white color rods in the reactor core. So, the first square is a reactor core, the second square in dark color is a protective shield and which is called as a pressure vessel, and above this there is a coolant that is act as a heat exchanger of from the heat produced, that is steam produced, which is used to generate electric power. Then the steam is converted into water and the water is again circulated to the heat exchanger. So, these are all the parts in the nuclear power. Let me see one by one. So, first one is fuel rods. The fissionable materials used in the nuclear reactor is enriched uranium 235. The enriched fuel is used in the reactor in the form of rods or strips. So, what do you mean by enriched uranium? So, you are all very well know it is a naturally occurring mineral. When we digged in the surface or in the mines, it will not come as uranium 235. So, it will come as uranium 239 or 236. So, from that we have to convert U236 into U235, that is what called enriched uranium. So, this is used as a fuel in the light water nuclear power plant. Then control rods. What do you mean by control rods? To control the fission reaction, that is rate of reaction, movable rods made up of cadmium or boron are suspended between the fuel rods. These rods can be lowered or raised and control the fission reaction by absorbing excess neutron. So, when excess neutron produced, when we inserting these control rods in between the fuel rods, what will happen? The control rod absorb the excess neutron in the reactor core. That will be clearly mentioned in the reaction. So, cadmium, boron, both are act as control rods. So, it will absorb neutron in the reactor core, excess neutron in the reactor core, thereby the chain reaction is controlled. Then moderators, the substance used to slow down the neutrons are called moderators. So, fast moving neutrons are converted into slow moving neutrons. So, usually moderators are ordinary water, heavy water, graphite or beryllium are used as a moderators. So, what will happen? The fast moving neutrons having kinetic energy of 1 milli electron volt is reduced to slow 0.25 electron volt. Thereby, the fast moving neutrons are converted into slow moving neutrons. The fourth one is coolants. So, in order to absorb the heat produced during the fission, a liquid called coolant is circulated in the reactor core. It enters the base of the reactor and leaves the top. The heat carried by outgoing liquid is used to produce steam. So, during the nuclear fission reaction, release of energy which will be absorbed by the coolant, the coolant enters at the bottom and exit at the top. So, thereby it carries the excess heat to the heat exchanger. So, usually water will act as a coolant. Then pressure vessel, it encloses the core and also provides the entrance and exit passage for coolant. So, pressure vessel which contains fuel rods and control rods, which also contains one inlet and one exit for coolant. Then protective shield. The nuclear reactor is enclosed in a thick massive concrete shield more than 10 meters thick. So, we are all very well know that alpha, beta, gamma radiations, all the three radiations are very dangerous in nature. That too, the gamma radiations are very, very dangerous. So, we have to protect these from the atmosphere. So, for that, the protective shield which is constructed over the reactor core, which is having a 10 meters thickness of concrete wall. So, the function of protective shield, the environment and operating personnels are protected from the destructive in case of leakage of radiation. Then the seventh component is turbine. The steam generated in the heat exchanger is used to operate a steam turbine which drives the generator to produce electricity. Then working of this light water nuclear power plant. So, the fission reaction is controlled by initiating or removing the control rods automatically from the spaces in between the fuel rods. The heat emitted by the fission of uranium 235 in the fuel core is absorbed by the coolant light water. So, once we insert the fuel rods, we will remove the control rods, then the chain reaction starts with the thermal neutron. So, after the chain reaction, the heat produced is carried by the coolant to the heat exchanger. So, the heat exchanger, what will happen? The steam which rotates the generator, thereby electricity is produced. The heated coolant water at 300 degrees centigrade then goes to the heat exchanger containing seawater. The coolant here transfers the heat to seawater, which is converted into steam. The steam is then drives the turbines, generate electricity. Though nuclear power plants are very important for production of electricity, they will cause a serious danger to the environment. What will happen? So, the disposal of nuclear waste is the problem. It is a very big headache to the authorities, how the nuclear waste will be disposed. So, disposal of nuclear waste is another important problem, because the fission products Ba or Kr are themselves radioactive. They emit dangerous radiations for several hundred years. So, the waste is placed in a concrete barrels which are buried deep into the sea. So, what will happen? Usually the radioactive waste, that too the reactor core waste, which are all put it into the concrete barrel and shield the concrete barrel. The concrete barrels are then taken to the sea and buried into the sea. So, even they are going to the deep sea and buried it. So, thereby avoiding leakages, thereby save the earth. Thank you very much for your patient listening. Thank you.